Welcome to ARCA Advanced Processing. We're going to change appliance recycling, and here's how. Hi, my name is Brian Connors, and I'm the President and Chief Operating Officer of ARCA Advanced Processing. I'd like to share with you today how an appliance reaches its end of life. Ever wonder where your old appliance goes? It ends up in a facility like ours. There are hazardous materials, there are recoverable materials, and there are metals. All need to be recycled and all need to get to the end user. Appliances arrive at our facility every day. They come in tractor trailers and they come from retailers. There'll be washers, dryers, ranges, refrigerators, and any other major household appliance that you may have traded in at a local retailer. They arrive at our facility, they're unloaded by hand, and we begin the recycling process. The cords are removed. If there are mercury switches in it or any other hazardous materials that's easily removed at first touch, we'll get them at that point. There are other hazardous materials that will be removed later in the process, but on first unloading, it's the cord, any mercury switches, and the units are identified for which process or which lane they're going to enter. Here you see refrigerators moving down on slip sheets on gravity rollers, and the unit here is going to be prepared to have its refrigerant recovered. As they load it onto this conveyor, it's loaded on its side and it reaches a working height for the mechanic to recover the refrigerants. Each station has its own dedicated job. In the case of a refrigerator, the refrigerants have to be recovered. In a case of a freezer or any other item that gets cold, it also has refrigerants that need to be recovered. Here you're watching a mechanic prepare compressors for export. These compressors might have residual oil in them, or they might have arrived at our facility from a wholesaler or a contractor where the oils haven't been recovered. Once the appliance reaches through our system, we now are in the business of recycling the metals. And the way we do that is we use a 2,000 horsepower high-speed hammermill shredder. This was manufactured for us under our own design, and it was made by American Pulverizer. And you'll see units here being loaded onto their conveyor belt. They've now left our building and are on the back side of our building, and they're going to enter a 60-inch wide conveyor that will take the unit up to the top of the shredding system. And you'll see here as they're entering the system, we have maybe a little bit of dust being created and steam. We're injecting water at this time. This keeps the dust down, and this keeps the process inside the hammermill shredder cooled. At the moment you're watching our shredder open, this is a maintenance mode. This doesn't happen during normal business hours. We're opening it to actually show you the inside of the shredder. This is a 60-inch wide by 60-inch in diameter hammermill shredder, and you see here that the hammers, they are pinned to the rotor. This rotor weighs 33,000 pounds, and those hammers weigh about 185 pounds. As you can see, the hammers will rotate 360 degrees on those pins. And these hammers are spinning at a tip speed of about 160 miles an hour. As appliances enter the hammermill shredder, there's only a pinch point of about 6 to 8 inches where the appliance can get through. We have a 33,000 pound rotor spinning at 720 RPM and with a tip speed of about 160 miles an hour, and the hammers impact the appliances. And they impact the appliances so hard that they actually are ripped into pieces. As the appliances enter the hammermill, they are dragged under the rotor and broken up into pieces as they rotate around the hammers. These pieces are sized by grating on the bottom, which you can't really see in this picture, but the material will fall through the grates onto a vibrating conveyor. That vibrating conveyor will present the commingled materials, the copper, the aluminum, the steel, and the foams and plastics, all to the first station. That first station is a rotary drum magnet, and that rotary drum magnet is actually pulling the steel out of this waste stream. That steel will then present to another drum magnet to further clean it, and then it goes through a picking station. And as you can see here, the picking station, we have 2 workers who are inspecting the steel before it's finally delivered. They're looking for things like wound rotors, they're looking for copper, they're looking for trash, they're looking for fiberglass, anything that could have gotten pinched in or held on to the steel. Things that would be undesirable to the steelmaking process. At this point, the steel has been rolled up and granulated into a form that's ready to be introduced into a steel furnace. Here we are in the control center. This is a custom designed control package that controls every machine in our plant. It's a wireless remote control system. The operator is actually at the front of the machine where material is being loaded onto the shredding system, and he has control of all aspects from that point. But this is the box that controls everything. This is a fully integrated PLC system that has alarms and monitoring and tracking, and basically has all the information for our run times and our ability to operate, stop, start, and emergency stop everything in the plant. As the scrap material passes over this system, there's an eddy current field under the belt, and that field actually gets the aluminum to jump a fence. And that's how we separate it from the stream. As you can see here, and you look real close, if you watch the aluminum pieces, as they get to the end of the belt, they sort of have a little bit of oomph and they jump right off. Below there's a box that collects that material. These boxes are fully processed, clean, ready to go to a customer. People buy this material and it's fully recyclable. You're watching the non-metallic materials now that are free of aluminum, copper, and all recyclable materials. This is what's entering our baler. At this point, this is what's going to the landfill. This represents about 25% of the appliance stream that's coming through. Most of this is currently landfilled because the recycling technologies in the United States haven't reached a level to recycle all of this material. We'll be the first to bring a URT system to the United States that will recycle the foam, that will also recycle a heavier percentage of the plastics, hopefully reducing the current waste that AAP puts into the landfill to below 5%. Currently at ARCA Advanced Processing, we're recycling somewhere between 75 and 78% of all the materials that enter in our facility. We're constantly striving for additional markets to up that number. In approximately 9 months, we'll be receiving a URT recycling center from Germany. This will allow us to recycle refrigerators in a completely separate line from our current process. That system will recover the foam insulation, and that foam insulation looks like this. And every refrigerator that's made has some type of insulation in it. Depending on when it was made, this insulation was blown with a blowing agent, and older refrigerators were blown with CFC-based blowing agents. Newer refrigerators are blown with HCFC blowing agents. And that new system that's going to arrive in the next 9 months will allow us to recycle refrigerators and capture those gases. When we can process that foam and turn that foam into a fuel, we will be recycling approximately 95% of all materials that come through this facility, reaching a goal of 5% landfill materials.